Hello students, so today we will solve these 4 basic questions of mechanics which you often find in exams, this kind of questions. So let us start and solve. We start with the first question. So first question says a 5 kg object is suspended by a string from the ceiling of an elevator that is accelerating downward at a rate of 2.6 meters per second square. What is the tension in the string? So you can see a diagram has been given here. This is the elevator. Inside that a mass is suspended through a string and we have to find the tension in the string. So for solving such kind of questions in mechanics, actually first thing you should do, you should draw the free body diagram. So here the free body diagram of this block hanging through the string, we can draw like this. All the forces we will show on it. So this is the weight of the block, suppose this is mg, and upward tension force applied through the string on this block, and under the influence of these two forces the block is moving downward with an acceleration of 2.6 meters per second square as given in the question, and the mass of the block is 5.0 kg. So you know there the net downward force in which direction the block is moving, so in that direction net downward force, that will be mg minus t, and according to Newton's second law this should be equal to mass times acceleration. So you can put the values and you can calculate easily tension force T from here. So that will be T will be equal to M times G minus A. And if you put the values, M is 5.0 kg and G is 9.8 meter per second square, minus acceleration is given 2.6. So if you put the value and solve it, 9.8 minus 2.6, 8 minus 6 will be 2, 9 minus 2 will be 7. So 5 into 7.2, this will be 5 to jar 10, 1 carry, 5 so in the 35 plus 1, 36 Newton. So the tension force in the string will be 36 Newton. So let us see which is the correct answer. The correct answer will be first answer, which is 36 Newton. So this was first question. Now let's come to the second question. So the second question says, two blocks are accelerated across a horizontal frictionless surface as shown. Frictional force keep the two blocks from sliding relative to each other, and the two blocks move with the same acceleration. If capital F equals 1.2 Newton and capital M equals 1 kg, what is the magnitude of the horizontal component or frictional force of the large block on the small block? So here also, if you draw the free body diagram of the two blocks separately, or simply in the first step you can consider the two blocks as a single system. So suppose this is a single system and net force applied on it is 1.2 Newton. So you can find its acceleration. So total mass is here 2m plus m 3m. So net acceleration here, or you can say the common acceleration, because the two blocks are moving together, right? It is said in the question that the two blocks move with the same acceleration, so they are moving together. So the common acceleration A will be net force divided by total mass. Total mass is 3m, and if you put the value F is 1.2 upon 3m, 3 into mass m is given 1 kg, so this is 0.4 meters per second square. So this is the acceleration of both the blocks. Now why the smaller block is moving here? Because you have applied a force on the bigger block only, right? So a force has been applied on the bigger block, but no force is directly applied on the capital M or a smaller block. So why it is moving with the bigger block? Because there is a frictional force acting between the smaller and bigger block. So frictional force will be acting on this smaller block in the forward direction. Let us say this is small f, and the reaction pair of this small frictional force or small f, that will be acting in the backward direction on the bigger block. So these are action reaction pair acting in opposite direction. And we don't need to care about the bigger block, we can just consider the smaller block to get the frictional force, because on the smaller block what are the forces? Its weight downward mg, the normal force n, and no other force. And because there is no vertical motion, so net vertical force should be 0, and it is moving in the horizontal direction with an acceleration of 0.4 meter per second square, which we have just calculated. So net acceleration is in the forward direction, so net force will also be in the forward direction, and that force is the frictional force. So you can write net frictional force F will be mass times acceleration, and mass is 1 kg here in the question, yes, and acceleration is 0.4 meter per second square. So frictional force is coming 0.4 Newton. So let us see which is the correct answer. 0.4 Newton, that is the answer C. That's the correct answer. So I hope you understood this question. Now let's come to the third question. So third question says a toy car with mass 0.8 kg travels at constant speed on the inside of a track that is vertical circle with radius 5 meter. If the normal force exerted by the track on the car when it is at the top of the track is 6 Newton, find the speed v of the car at that point. So let's draw the free body diagram of the car when it is present at the top of the circle. What forces will be acting on this car? One will be its downward force weight mg, plus it is moving on the track, so track's normal reaction force will also be downward n, and these two forces together will provide the required centripetal force, because any body which moves on a circular path, it requires a centripetal force, and any natural force, any force present in nature, that acts as a centripetal force. So net force towards the center here, suppose this is the center, net force towards the center, that will provide the required centripetal force. And suppose speed v of the car is v, then net required centripetal force will be capital M, or where M is the mass of the car, mv square upon r, where r is the radius. And what will be the net centripetal force here? The two forces which are providing, or which can provide the centripetal force here, are these two, mg weight and normal reaction of the track n, and both of these two are acting towards the center, so they together will provide the required centripetal force. So let us write mg plus n, that is equal to mv square upon r. Let's put the values. Mass is given 0.8 kg, g is 9.8, plus normal reaction is also given 6 Newton, and this is equal to again 0.8 into v square divided by radius is 5 meter. And let's put the values and solve this. So 8 8 are 64, 6 carry, 8 9 are 72, 78, and after 2 digits decimal 7.84 plus 6, and this will be 0.51 are 5, 5 6 are 30, 0.16 v square, or from here you can write v is equal to, this will be 7.84 plus 6, 13.84 divided by 0.16, and it was square, so it now will be square root. And let us see how much this will be on solving. So let's use the calculator, and square root of 13.84 divided by 0.16, and let us see how much it comes. It is coming 9.300, or we can simply say 9.30 meters per second. So speed of the toy car is 9.30 meter per second. So let us see which is the correct answer. So first answer is the correct answer, 9.3 meter per second. So this was question number 3. Now let's come to the last question, which is fourth question. Okay, so last question, fourth question, that says if capital M is equal to 2.0 kg, and then what is the tension in the string 1? So string 1 is the horizontal string here, and capital M, only these two things are given, and plus one angle is also given here in the diagram, if you see 30 degree. So let's draw the free body diagram of this common junction point, this point which is joining, where the two strings are getting joined and the block M string is also getting joined here. So this is also in equilibrium, as the whole system is in equilibrium. So let's draw the free body diagram of this common junction point. So this is the point. One force will be on the left through the left string or string 1, suppose that tension force is T1. Another tension force will be coming through the other string, suppose that is the T2 force, and because this angle was given 30 degrees, so if you draw a horizontal direction here, this angle will also be 30 degrees, because they will be alternate angles. And one downward force will also be acting on this point because of the weight of the suspended block, so that will be mg. So only these three forces are acting on this common junction point, and under the influence of these three forces, this suspension point or this common junction point is in equilibrium, so net force will be 0. So if you resolve the forces, the T2 force only in the horizontal and vertical direction, so T2 can be resolved as, here it will be T2 cos 30 degree, and in the upward direction it will be T2 sin 30 degree, right? So because you have resolved the T2 into components, so now the T2 will not be there, T2 has gone, and it has got broken into two parts, T2 sin 30, T2 cos 30. So you see there are two forces in the leftward and rightward direction, and two forces in the upward and downward direction. So for equilibrium of this point, net force should be 0. So net upward force T2 sin 30, that must be equal to net downward force, that is mg, and net leftward force, that should be equal to net rightward force, so T2 cos 30, that must be equal to T1. So you have these two equations. What we can do, we don't know T2, so solving this, and we also don't know T1, so we have two variables, two equations, we can solve this. So to solve this kind of equations, what we should do, we should divide these two equations. So if you divide these two, then T2 will get cancelled. As you can see, if you divide these two, then T2 gets cancelled and you will have sin 30 upon cos 30, that will be tan 30 degree, and this will be equal to mg. M mass is given as 2.0 kg into 9.8 of value of g and divided by T1. So from here you can write T1 is equal to 2 into 9.8 will be 19.6 divided by tan 30. If you know, that is 1 by under root 3. So this will be 19.6 under root 3, and if you multiply it 19.6 by under root 3, let us see what it comes. 19.6 into square root of 3. This is coming 33.94 or 33.95, or simply you can write 33.9 Newton, or let's see what are the answers. So 33.9, okay, 34 is the closest answer, so 33.9 can be written as 34 Newton. So 34 Newton is the tension in the first string or string 1. So that's the correct answer. So answer to this fourth problem is C. Tension in the string 1 is 34 Newton. So I hope you understood these 4 questions, and you also liked the way how I solved it in a shortcut way or in a simple way, but still we have written all the required concepts. So if you like this video, please consider liking this video and subscribe my channel also, and consider sharing these videos with your friends also. So keep watching my videos. Thank you very much. Take care and bye bye.